Hello everyone. In this video, we cover conditional probability. Before we move on to conditional probability, let's take a look at two types of probabilities, the marginal probability and the joint probability. So what is marginal probability? Marginal probability is the probability of a single event without consideration of any other events. It is also called simple probability or unconditional probability. For example, if we roll a six-sided die once, and we are interested in whether the number is an even number or not. So the probability of getting an even number is a marginal probability because we focus on one event, whether the number is even or not. Or another illustration, we are interested in the probability of getting the number greater than 3. So here we focus on a single event, whether the number is greater than 3 or not. So these two probabilities are called marginal probability. How about joint probability? The definition. The probability of the intersection of two events, A and B, is called the joint probability. For example, in rolling a six-sided die once, the probability of getting a number which is even and greater than 3 is a joint probability. Here, we focus on two events, whether the number is even or not, as well as whether the number is greater than 3 or not. So this probability is a joint probability. Let's move on to conditional probability. The definition of conditional probability is as follows. The probability of an event A, given that an event B has occurred, is called the conditional probability of A given B. In notation, we write this probability as P with bracket A, the vertical line, and then B. This vertical line denotes the phrase given that. And then the expressions on the right of this vertical line is the event that has occurred, the conditional probabilities, P of A given B. For example, if we want to get the probability that in rolling a six-sided die, the number is even, given that the number is greater than 3. So here we get an updated information. We already know that the number rolled is greater than 3. Then we calculate the probability that this number is also an even number. So written in the notation, this could be written as the probability of an even number, given that, replaced by this vertical line. And then the phrase after this vertical line is the given condition, given that the number is greater than 3. Let's take a look at the Venn diagram. We have two events, event A and B. If we want to get the probability of event A, so this is equals to the number of events that corresponds to event A over the total number of events in the sample space, NA over NS. And suppose we want to get the probability of the intersection of A and B, the events corresponds to both event A and event B. Such probability is equals to N of the intersection of A and B over NS. And recall that the middle region, the overlapping region in the Venn diagram, corresponds to the intersection of A and B. Working on conditional probability, suppose that we are given that event B has occurred. Then we only need to focus on event B, the circle B in the Venn diagram. Circle A is no longer relevant if we are given the information that event B has occurred. So we are interested in all the outcomes corresponds to event B. And now event B is a new sample space under the condition that event B has occurred. And then from that, if we want to get the probability that event A also occurred, then this corresponds to the outcome that falls in the intersection of the two circles. Okay, so here, if we know the information that event B has occurred, then the sample space is no longer the original sample space S. Instead, event B is now the sample space. This is called the reduced sample space. If we want to get the probability that A also occurred, then this corresponds to all the outcomes belongs in the intersection of A and B. So what is the corresponding probability? The probability of getting event A given that event B also occurred. This conditional probability is equal to the number of events corresponds to the intersection of A and B over the number of events corresponds to event B, n of the intersection of A and B over MB. And this is equivalent to the probability of the intersection of A and B over the probability of B. This is the expression in computing the probability of event A occurring given that event B has occurred. Therefore, for two events A and B, with the probability of B greater than 0, the conditional probability of A given that B has occurred is shown below. This is the formula. And then similarly, for two events A and B, given that the probability of event A is greater than 0, the conditional probability of B occurring, given that event A has occurred, has the following formula. So we just swap the event B and event A in the two formulas. So the probability of B given A is equal to the probability of the intersection of A and B over the probability of A. And in general, the two conditional probability are not the same. Let's take a look at an example. In a recruitment exercise of a public organization, applicants have to pass a written test and an oral test in order to be qualified for the final interview. The passing rates for the written test and the oral test are 68% and 75% respectively. Only 53% of all applicants pass both tests. So here we have the probability of passing the written test equals to 0.68, and then the probability of passing the oral test is 0.75. We are also given the information that 53% of all applicants pass both tests. So the probability of passing both the written test and the oral test equals to 0.53. From the information above, what do we want to find? Here's the question. For a randomly selected applicant, what is the probability that the applicant passes the written test, given that he has passed the oral test? So here we need to find the conditional probability. We are given that the applicant has already passed the oral test. And what is the probability that the applicant also passes the written test? The probability we need to find with a simple probability written given oral. Given he passed the oral test, what is the probability that he also passed the written test? So using the formula, this is equal to the probability of passing both tests over the probability of passing the oral test. We get all the numbers. The probability of passing both tests is 0.53, and the probability of passing the oral test is 0.75. Plug into the formula, and then we get the probability that the applicant passes the written test, given that he has passed the oral test, equals to 0.7067. Let's do the reverse. What is the probability that the applicant passed the oral test, given that he has passed the written test? Now we know the condition that the applicant passed the written test. So here we have an expression in obtaining the probability of passing the oral test given the applicant passed the written exam. So this is equals to the probability of passing both tests over the probability of passing the written test. Plug in the formula, we get the probability equals to 0.7794. In summary, we can see that the two probabilities are not the same. The probability of passing the written test given the oral test has already passed versus the probability of passing the oral test given that the applicant already passed the written test exam. These are the solutions to these two conditional probability. And that's it for this video. And thank you for watching. In the next video, we talk about independence events.